Hello. In the last session, we reached up to the definition of machine and mechanism. The other thing which we did not discuss was structure. Now let us again go through what or how we have defined machine. See what we have defined machine. Machine as combination of resistant bodies so arranged that by their means the mechanical forces of nature are compelled to do work. Again here by work we mean mechanical work as far as our study is concerned, and that too we are calling this to be as useful work. I'll come to it how we are calling this to be as useful work accompanied by certain determinate motion. Now determinate motion we mean some specific motion. So if you see, these will form the keywords for us. Useful work, right? Resistant bodies. Now these are the keywords which are there in this particular definition, if you see. So now what do we mean by useful work? We'll come to it once we first go through the definition of mechanism. What we define or how we define mechanism as assemblage of resistant bodies. If you compare these two things, you'll see that we are calling, okay, combination is also assemblage of bodies together. So assemblage of resistant bodies connected by movable joints. So in this case the keywords comes out to be one of the prime factor as movable. The joints which are there are movable joints to form a closed kinematic chain. Again we will go through this term, closed kinematic chain with one link. Again this term we have not talked about. So what is link? Fixed. So chain with one link fixed and having a purpose of transforming motion. Now if you just compare these two definitions, here it is work is one of the keywords here, and here no such term is utilized in case of mechanism. So here the sole intention, if you see, is of transforming, either transferring or transforming motion. Try to remember the example what we have considered that in the last session was a simple piston cylinder arrangement. So this is the cylinder, this is the piston. So with piston we connected another member. With this connecting rod we have again connected another member, and so when the piston is pushed, this body is getting pushed, and so this body is turning, right? So when we have discussed, we have not talked about by how much force, how much torque the last link or last member or last body is supposed to turn, right? So that means here we were framing, so we were talking about a mechanism. Now the moment we talk about, okay, I have to carry say 4 people in my car, so that means in that case I'll be taking into account the load, fine. So if I am taking into account the load, that means the force or whatever. So here what is having in or what is happening in case of a machine is the intentions for a machine is to transmit and modify available, it can be mechanical energy or for that matter any energy into desired work. So this is the intention of a machine, or what is machine doing? It is transmitting or modifying the available mechanical energy or for that any energy into desired work, the work which I need to do. Whereas in case of mechanism, if you see, the intention is to achieve desired motion only. So purely our intention to modify or to achieve desired motion. Now this will be more clear when we take up certain examples. Now in day-to-day life there are so many equipments which we are using, fine. So we can categorize them into machine or mechanism by just looking into or by just studying the output of that component. Now In case of machine, very well I can quote example as very simple to understand car or a vehicle. Now here you can see, in case of a car, the car is capable not just to carry its own load. See, a car is having considerable weight, so the engine of the car or the arrangement of the car is not such that it is able to carry just only its load. As well, with its own load, it can carry number of people as well sitting in it. So there we are counting it. So that work we are calling it to be as a useful work, right? So if I say a car, then car comes into a example of machine. In comparison to that, all of you must have seen a clock or a watch. Now, if you see the arrangement of of a clockwork, it is very complicated. There are so many components involved in it. But what is the useful work it is doing? If you see, the clockwork or the watch needs only energy just to move the hands of minute, second and hour. Nothing more than that, and just to overcome the friction in it. So in case of a mechanism, so I will put this into or take this as an example of mechanism, because here the energy or the work required is only to lift its own weight and overcome the friction. Whereas if you see here, in case of a machine, it is definitely lifting its own weight, overcoming the friction, and on top of that it is able to carry number of people sitting in it or a load put on that. So that it is doing the extra work, or that we are calling it to be as a useful work. So you will see that there will be definitely a very fine borderline between a machine and a mechanism. So we need to properly see the what output that particular arrangement is giving us, based on which only we can decide whether this is coming into the category of a machine or it is coming into the category of mechanism. Second example can be a typewriter. You must have seen typewriter. How much power we need? We just need the power to move the alphabet component and just touch the paper. The alphabet is printed. Now if I hit it hard, it is going to tear the paper, right? So I just need to overcome its own load and friction and to touch the paper, nothing more than that. So again, though it looks a very complicated arrangement, of course, in kinematics that will come into the category of mechanism. Whereas in comparison to again typewriter, if you see a screw jack for that matter, when the screw jack for what a screw jack is used, you must have seen. So to change the wheels of a vehicle, we are using a screw jack. Hardly there are 2 or 3 components in a screw jack. It's a very simple arrangement, but it can overcome its own weight of the screw and that arrangement, plus it can even lift the entire vehicle. So there again it is doing the extra work or the useful work. So definitely I can say a screw jack will come into, though the arrangement is very simple, but still it will come into the category of machines. Now the third thing which we were talking about is structure. Again, if you see a structure also we can define it as assemblage of resistant bodies connected by joints. Again, here also we are saying that they are connected by joints, but these are not movable joints. So here you will find out that there won't be any relative motion between the two members involved in a structure. For example, a truss or a bridge, if you see, or a table or a chair, it is made up of so many components joined together, but all these joints are fixed joints. So you won't see that there is a relative motion between the members. Whereas if you see our body, this is a beautiful example of a machine and a mechanism. So this link is connected to this link with the help of a joint, though these two are joined together, but there exists a relative motion between the two members, so it forms a mechanism. Of course, if I am able to lift a load, that means certainly this is a machine. So it is lifting the own weight of the bones and muscles and everything. On top of that, it is able to lift some other load as well. So this is acting as a machine. Fine. So that is how we can categorize. So in context to the study of mechanisms, if we see, that day we have formed one kind of a chart. So there we can see an analogy between, so mechanics we have talked about. Mechanics is the study of time, motion and forces. This we have divided into, the basic division of study is statics and dynamics, right? And again, this the dynamic is study of dynamics is subdivided into two studies, specifically the kinematics and kinetics, right? So now if you want to establish the analogy of what we have studied, so statics is to structures, kinematics is to mechanism, and kinetics is to machine. Just try to understand the intentions. In case of structure, the intention of the structure is not to do work or transmit motion. The intention of a structure is not to do any kind of work or nor to transmit any kind of motion. Its intention is just to bear load, or this is intended to be rigid. It has to be rigid. By rigid we mean that it is able to sustain for the given force conditions, right? Kinematics is to mechanism, wherein that means we are considering, or our intention is to achieve only desired motion. Like in case of example we have quoted clockwork. I just want that minute hand or hour hand or a second hand to just to move, so specifically at a given time, right? So our intention is just to have or achieve desired motion, whereas in case of a machine it needs to do work, right? So here we are talking about only motion. Here we are talking work with determinate motion. So with a specific, so work and motion both are involved in case of kinetics. So that is how we can say. So the input in case of this is forces or energy, output is work done. Here in case of mechanism, input is motion, output is desired motion, right? In case of structures, the input is load, the output is of bearing that load, or how it is going to react for support that load. So that is how we can say these three things are understood. Fine. So if we have used certain terms in case of in the definitions like link, kinematic chain and all. Let us just try to see or try to understand what a link is. So instead of link, I'll call it as a kinematic link. Now, why we are using this term kinematic? Kinema means motion. So this link, whatever you are talking about, here motion is involved. Fine. So what is a kinematic link? Of course, these are the rigid bodies or the resistant bodies. The various components. by which we mean the components of a machine or a mechanism. They are supposed to be rigid. Why? Now, again, in case of in kinematic studies, we are representing links only by only one dimension, that is the length. We are not bothered about the cross section, right? So, like if you see the connecting rod of an engine, it will more or less look something like this. So we are not considering the cross section here. So there is no consideration. What our intentions are? Now if I go through the axis, see, so I am forming a joint here and a joint here. So anyway, if this body moves, every body is going to have relative motion with respect to that. And now our intent, so we are representing simply link as a simple line with these two ends, or we are calling these two as the joints or the kinematic joints, right? So now what these links are, they need to be rigid. By rigid, what we mean, so if I am applying some kind of force, so when there is this force applied, this link is pushed. Now if this is rigid, then if I consider 2 points on this link, let us say A and B, so when I push it, so it will move somewhere here at the, say this is the first location, this is the second location. But now if we see the distance between A and B at any location, these two distances are not going to change. Then only I'll call this as to be rigid. Because if it is flexible, say if I apply a load and this body bends like this, so A will have a displacement, but B will not have any displacement. So if the location or this other end of the body does not have any movement, then the motion is not transmitted. That is why in our study of kinematics, the assumption is that all these components are supposed to be rigid for the given force condition or resistant bodies. Fine. So this is called, so we are calling these members or every components as the links. Now I have one link here. Definitely it's not possible for me to transmit or transform motion just with the help of one link, right? So I need to involve various components and they are to be joined together. So say with this I join another link. So this is link number 1, this is link number 2. Now in case of, so we are calling this, so when I am joining these two links together, so I am forming a kinematic pair. Again, definitely it has to be a kinematic pair. In further studies, we will only call as pair, link. We will not use this term as we are in the kinematic study. Fine. So when we are joining the two links together, we are forming, so this, let us say number 1, number 2, so we are forming a kinematic pair. Now how kinematic pair is formed? A kinematic pair is formed with the help of a movable joint. Very simple example of hand, if you see, say this is the upper arm, this is one link, this is one bone, and this is the forearm. This is the second link, second member. They are rigid and we are joining them together. They are definitely connected to each other, they are joined together, but the joint is a movable joint, right? So it is forming a kinematic pair. It is forming a kinematic pair. Fine. So thus, now if we move on with it, so if I take the example of hand, this is one link, this is another link, but again there is another link added to it to lift the load or to do whatever my intentions are. So again I am joining another link with this link. So I am forming a pair with link number 1, I am forming pair with link number 2. Then I am joining a link 3 with the link 2, again with the help of a movable joint. And again maybe I am joining a link number 4 to the link number 3, then another link 5 with link number 4. So likewise I am forming a kinematic chain. So we are forming a kinematic chain. This is the third term. We have used the term kinematic chain, right? So we are forming a kinematic chain. Now if I join the last link, let us say there is a sixth link, and I join the sixth link with the link number 1. So I am joining the last link of the chain with the first link of the chain. So it is forming a closed chain. Right? Now if I am not joining, let us say if there are 5 links, if I am not joining the last link with the first link, it will be an open chain in that case. Right? So that is how we are forming. So we have used that term, closed kinematic chain. Fine. So if I am joining the last link with the first link, then we are forming a closed chain, right? So now what is a kinematic chain specifically? Now for that I'll take a very simple example. Say there is link number 1, I join link number 2, then link number 3, and this is link number 4. So the link number 1, link number 2, link number 3, and link number 4. Just have a look at this arrangement. All these links are rigid links, they are not flexible. Fine. Now I call this link number 2, let us say, be the input link where I am giving the motion. Right? So let us say I turn this link. I turn link number 2. Now as this is rigid, so I name these joints. Let us say this is joint A, this is joint B. Just have a look at this situation. Now when I am, so this is link number 2 which is joined here. When I am turning it, you'll see that what will be path of the joint A. Now as joint A is part of link 2, this joint A will have a path equal to the radius of link 2. Fine. So let us say I turn this link number 2 by some angle theta. So it takes the location as this. So this is, say, A dash position. Fine. Now link number 3 is also a rigid body, so it is not going to bend. So if I move, see how this A has moved, the A has moved forward and came down. If it is so, then this link will move ahead. So when this link move ahead, so definitely again the length of this link 3 is not going to change. And just think about the joint B. Again joint B will have a locus or path with the radius of link 4. So definitely the other end of link 3 must be on the path of B, and the distance between A and B must not change because they are rigid. So if I take this distance from A dash and I mark it, so I'll get this as, let us say, I get this as B dash. That means this is the position of link number 3 now, and this is, so if this is moved, then the link number 4 has also turned. So if I turn this by some theta, so maybe the link number 4 has turned by some angle phi. So now if you see, when I move one link, every body here is having a relative motion. So when all bodies will execute a relative motion, then only it will be called as a kinematic chain. Whereas if I see, quote an example, if I take say 5 link mechanism, just see here. Now if, so this is 1, this is 2, this is 3, this is 4, and this is 5. Now if you see, if I turn link number 2, chances are there that 4 and 5 just simply turn like that, and there cannot be any motion between 4 and 5. So here it is not determinate. Whereas here it is determinate that if at all I move 2, all members will have relative motion, whereas in this case if I move link number 2, I cannot predict what will be the motion of 5. So this does not comes into the kinematic chain. This will be just a chain right now, but we can make it a kinematic chain. So that is how we understand what is a kinematic chain. And when we fix one link of a kinematic chain as a frame, it becomes a mechanism. So when we fix one link or one member of a kinematic chain, it becomes a mechanism. That is all for this session.